Alright, hello. Welcome back. We have 6.7 modeling with exponential functions today. I just first want to say I really enjoyed reading the week 13 participation and seeing how you guys are doing or hearing how you guys are doing. And I'm really proud of you guys for making the most of the situation. It was really nice to read your comments. Anyway, I am going to keep on going here. And I'm going to start with a little vocab. Finite differences right here, and that's the differences of the consecutive y values in a data set when the x values are equally spaced. And when we go ahead into concept 1 where we classify data sets, we are going to ask ourselves every time, are the x values equally spaced? Alright, and then we'll look at the y values, or the pattern, which is going on. Alright, the second vocab is common ratio, and that is the constant ratio R between consecutive terms of a geometric sequence. And that pattern of the y's would be a set of multiples. Alright, that means we have a different set, it's a multiple between each number. And that will let us know it's exponential function. And that's really key, and that's really the new thing that we're talking about because we are in the unit of exponential functions. Alright, there are other possibilities though, and that is dealing with a constant difference, adding or subtracting. And the first difference, like if the first set you have a constant difference, then that is a linear function. And then if it takes two efforts to get there, then that is a quadratic function. Alright, the second set is consistent. Alright, so here we go. Concept 1, determine the type of functions represented by each table. Alright, so the first thing I'm going to do is look at the x values and are they equally spaced? Well, yes, in number 1 they're equally spaced by 1. Difference of 1 between all those numbers. Alright, then I'm going to go ahead and find a difference between my y values. Alright, how do I get from a half to 1, and 1 to 2, and 2 to 4, and 4 to 8, and 8 to 16, and 16 to 32? Well, I am multiplying by 2. Each time. Alright, and that is telling me that I have a common ratio of 2. So, since it is a geometric sequence, that means what type of function do I have? An exponential function. And my common difference is 2. Or common ratio, you should say. And voila, 1A is done. 1B, same idea, okay? Are my x values equally spaced? Well, -2, 0, 2, 4, 6, 8, 10, yep, spaced by 2, right? Y values, how do I get from 2 to 0, 0 to 2, 2 to 8, 8 to 6, 8 to 18, 18 to 32, 32 to 50. Well, here, I know it's not a multiple, right? So I'm going to try the difference. So, it's the difference. So 0 minus 2 is -2. 2 minus 0 is 2. 8 minus 2 is 6. 18 minus 8 is 10. 32 minus 18 is 14, and 50 minus 32 is 18. The first difference of numbers is not constant, right? So it's not a linear function. I'm going to try again. And 2 minus -2 is +4. 6 minus 2 is 4. 10 minus 6 is 4. 14 minus 10 is 4. 18 minus 14 is 4. Alright, so our second difference, or our second difference is constant. Alright, so what does that tell us? It tells us it is, back up on top, a quadratic function. Alright, I do want you to try number 2, A and B. So give it a go. I'm going to go ahead and switch this paper out for the solution. So please pause now, give it a go, and then check your solution when you get back. Alright, here we go. Number 2, A and B. And number 2A is an exponential function. The common ratio is 1/3. B is a quadratic function. Alright. Alright, so here we go. I'm going to move on. Concept 2, writing an exponential function using 2 points. Alright, so we got our 2 points right there. And it says, write an exponential function y equals a times b to the x power whose graph passes through the point 1, 6, and 3, 54. Alright, so those are our x and y values, right? And all I'm really doing is I'm going to plug in those x and y values into this equation. But I'm going to have to do it twice. And the first time I do it, I'm going to use this one right here, 1, 6. And y is 6, so it goes 6 is equal to ab to the x power, which is 1. And anything to the first power is just itself, so that's 6 equals a times b. I'm going to divide by b to both sides to solve for a. A equals 6 over b. Alright, and what I'm going to do is then do it again and solve for b, plugging in to solve for my a in the end. That was probably a little confusing, but here we go. I'm going to take this equation right here, and I'm going to use a as 6 over b. So I'm going to use this second point in that. So y is 54 equals a 6 over b times b to the x power. In this case, it's 3. Alright, and I'm going to put times right there. And the first thing I'm going to do is b to the third power divided by b would be b to the second power. If I have like bases, which I do, I subtract my exponents. 3 minus 1 is 2. So I get 54 equals 6b squared. Next I'm going to divide by 6 to both sides. And I get b squared equals 9. Then I'm going to take the square root of both sides of the equation, and b is going to equal 3. Alright, and that's what I'm going to put in over here to solve for a. 6 divided by b, which is 3, a equals 2. Alright. Awesome. So now I got a is equal to 2, b is equal to 3, and I plug it back into that equation right there. Y equals 2 times 3 to the x power. And now I have our exponential function right there. Alright, that is concept 2. I'm going to solve for a and b and plug it back into the function y equals ab to the x power. And go ahead and give number 4 a try. Pause it right now. Alright, here you go. You should have y equals 5 times 2 to the x power for number 4. Alright, flip it on up, you guys. And we got really one more to go. Alright, here we go. Concept 3, finding an exponential model. A store sells trampolines. The table shows the number of trampolines sold during X years that the store had been opened. Write a function for the model of data. Alright, so first things first, maybe I just plot these points right here real quick, and I kind of already set it up a little bit. But here we go. 112, right about there. 216, here. 325, here. 436, here. 550, there. 667, right about there. And 796, right about there. Alright, now I have those points. I'm going to go ahead and draw my graph. And it looks something like this. Alright, and that is an exponential graph. And the next thing is to write the function. And that's exactly what we just did in concept 2. I'm going to pick 2 points. I'm going to plug them into our equation. This is the exact same thing as 112 and 436. And here we go. Plug them in right here. So what I have is y is 12 equals ab to the first power. 12 equals ab. Divide by b to solve for a. A equals b over 12. Alright, second part, I'm going to use this equation, plug it in with a. So I got 36 equals 12 over b, a, times b to the fourth power. B to the fourth power divided by b is b cubed, so I get 36 equals 12b cubed. Divide by 12 to both sides, I get b cubed equals 3. Alright, and here I got to take the cubed root of both sides. And we're going to plug that into your calculator, and you're going to get approximately 1.44. I'm going to put that right here, right? So a equals 12 divided by 1.44. Plug that in your calculator, and you're going to get approximately 8.32. And then you're going to use a and b to write your function. So y equals a, which is 8.32, times b, 1.44, to the x power. And voila, we have the function. There it is, you guys. Just what we did in the last one. So go ahead and pause yours. Give 6 a try. I'm going to go ahead and show the answer here. And here you go. I chose 2 points. Plugged them in to y equals a times b to the x power. And my function, y equals 9.94 times 1.71 to the x power. We are going to go ahead and skip concept 4. It is example number 4 on page 344 in your book if you want to take a look at it, but there are no problems in the homework on this. I have 9 problems for homework. Best of luck, you guys. Take it easy.